Hello everyone. In this video I'm going to demonstrate how we can train a model that can detect an object in an image or a video using Yolov5. So I will be using the custom dataset which I created in last video. So to get started with it, let's go to this link. I have posted this link in the description. Let's go to this link. This link basically has one Python notebook and dataset. So I have split the dataset into 3 parts: train, test and validation. You can see in train there are somewhere around 130 images, I guess, and in test there are 2 or 3 images and their annotations. So let's download this. You can clone the repository or you can just download the zip file. Let's download it in desktop, save. Okay, extract, new folder, Yolov5 example. Let's extract the dataset, so the files. So inside this you can see we have the Python notebook and the dataset. Together with the dataset I have also included one video to check whether our object detection model works or not. So let's go and start our Python notebook. So I recommend everyone to use Google Colab for the session here. So you can open your Google Colab and load this Python notebook, or there is also one beautiful service that you can open the Python notebook directly from GitHub. So for that, open the Python notebook in GitHub, and then we can just type GitHub to Colab. So you can open anyway in Colab. So you can see I have loaded my Python notebook. So the one thing I need to do at first is I need to upload my data into my Google Drive so that the Colab can access the dataset. So I will go to drive.google.com, and in my drive I will just copy. Okay, I will just upload my folder, Yolov5 folder. So let's wait until the uploading finishes and we can go to this. Okay, so let's run the first cell. So run anyway. So what this first cell does is it will mount our Google Drive into this notebook, so that this notebook will have the access to the data inside our Google Drive. So we have to authorize it first. Go to this link, and okay, I want to authorize this one, allow, and copy this key and paste it into this and press enter. So it will authorize this notebook to use our Google Drive. Now if you go to this file structure here, files, and wait, so inside content we have mounted drive. So inside drive there is my drive, and you can see the things that are in my drive. So let's wait for this dataset to be completely uploaded. you can also see the dataset file can be seen here. So in the meantime, let's go through another cell. So this cell, what it does is it will go to the GitHub repo of Yolov5 provided by the authors. So it will go to this file and it will clone this file in our runtime. So it will clone the repository, go inside the repository and install all the requirements for this for running Yolov5. So the requirements are here in requirements.txt file. So all these packages will be installed from this cell. So after everything is installed, we can just check if everything is installed or not. Okay, setup, it prints setup complete without any issue. That means everything is installed. Let me see if my dataset is completely uploaded or not. Okay, upload complete. So I can go to the next cell. So next step is to train the model. So we have the dataset that we created from the last video. Actually, I have used more images in this dataset. There is around 150 images, because if there are less number of images, our result is very poor. So whenever you are trying to create your own object detection model, so try to keep as much images as you can, otherwise the result will not be that good. Okay, so to train the model, we have few commands here, like few options for the command. So first one is image, where we pass the size of the image. So basically what you have to pass here is the size of the image that you resized into. So in the previous video I resized my image into 416, so 416, and there are other options for batch and epochs. Actually this is an introductory course, so these things about deep learning and machine learning is out of scope for the course. If you are interested, you can go through the internet and search, or otherwise you will be learning every basic things in next year. But basically what batch does here is, batch will group the dataset into the number of batches that we define. So for example, if we say batch 8, that means it will, from the whole dataset, or let's say from the training dataset, it will group the training dataset into 8 groups. And epochs means how many times we have to run the training. So if you want to go through it and understand more clearly, you can ask us individually, or you can go through the internet. And together with batch and epochs, we have to give the path for our YAML file as well. So YAML file is the file that is created while we created the dataset. Let's go through our YAML file. So in our YAML file, you can see it gives the location of training images and validation images, and also the number of classes and the name of the class. So we will, and other options are CFG, it's the configuration that we want to select. So for YOLO, we have 4 different configurations. You can see small, medium, large, X large. So the performance of the model depends upon which model, which configuration you select. For now we will only select the smallest one, so the performance is not the top notch, but it will train faster. So for just the demonstration purpose, we will select the small one. So I have selected a small one, and then there is another option called weights. So if you want to use the pre-trained weights and then you want to update, then you can use this option. So let's train our model. So for now we will just remove the batch and epochs, so that it will be default, because 10 epochs is too less, and it will not deliver any result at 10. Actually, when you want to work with your own custom model, you might want to make epochs in terms of thousands, so that your data will be correctly modeled, but you have to make sure it doesn't overfit the data. So regarding overfitting and underfitting, it's also beyond the scope of this course for now, but you will learn in next semester, I guess. Okay, for now let's remove these things, and we have just passed 3 options, and we will train. This issue says that dataset is not found. So let's go to our data.yaml, where we have defined the path to the dataset. So if you see in this line, it says it cannot find in this path. So actually this in this path we don't have our dataset. So the problem here is we have used relative path in our data.yaml. So our notebook is running in different runtime, so it cannot find the dataset using the relative path. So using instead of using the relative path, let's give the absolute path of the dataset. So to go, like, this is the home or root for the Google Drive, and inside Google Drive, so inside root, in content directory there is inside content there is drive, and inside drive there is my drive, where you can find all the files in my drive. So I have stored the dataset in Yolov5 folder. So here is the dataset. So let's change our data.yaml to have the absolute path. So absolute path is, so starts from root content slash drive, drive, my drive slash Yolov5. So same for the validation set as well. Validation set as well. Both of them are in the same location. So let's save this file and let us try to run this cell again. So once we run our cell, you can see our training process is about to start. It will print the summary of the Yolov5 model. If you are somewhat familiar with deep learning, then you can understand what this summary means. So these are basically the layers in the neural network, so which is again out of the scope for now. So let's just see what is going on here. So at first it scanned for the training images, and then it found 138 training images, and 6 of them were empty without any label. And for validation image, it found 9 validation images, and then now it's starting to train. So it will train for 300 epochs. That means it will train for 300 times. And you can see, so the number we are concerned here is MAP, mean average precision, at 0.5. So the value for mean average precision lies from 0 to 1. So if it is close to 1, that means the performance of our model is very good on the validation set, and if it is close to 0, that means it is very bad right now in the validation set. So if you see right now at the start, the performance is very bad. It is like 0.000 in terms of like that, but we have to wait until all the epochs complete, because as the training goes on, it will improve the result. So let's see, now it's only 32 epochs, so we cannot still see the improvement. let's wait for some time. So we have completed around 200 epochs, and now you can see the result is getting better. MAP at 0.5 is around 0.69, 0.73, so it's getting better. So that means our model is learning from the data. So let's wait until it is trained completely. So our last epoch is nearly finished. So now you can see our weights are saved in these files. The last one is the result from the last epoch. So the last result is 0.847 is the MAP. So it's way better than what we started with. And the best one is also saved here. So we have two different models. One is the last one, which is this, and the best one. So the last one is not always the best one, because in sometimes our model makes mistake, but on the long run it will always improve and keep on improving. But from one epoch to another epoch it can sometimes decrease the performance, but it will ultimately increase in the long run. So if you see, our last model performed last epoch performed 0.847, but you can see these models are 0.86 or something. So anyway, the best weights are saved in this directory. So now let's copy the best weight. So best weight is in runs train exp4. You can see from here exp4 best.pt into our drive. So whenever you see in Jupyter Notebook, in front of the command, if there is a exclamation sign, that means we are going to run the bash script or Ubuntu command line tool, command that we learned in the previous robotics lab. So this is basically copy this file from this location into this location. So next we will detect the objects from other images. So now for this we will use our test images. So the test images are saved here. Basically we only have 3 test images. Let's see our performance of our model that we trained for test images. For this we just have to call this command detect.py with weights. We will pass the best weight that we copied from this folder, and there is a confidence score. So what confidence score does is, whenever our model finds some object, it will give a confidence score whether that object is the screwdriver or not. So let's say the confidence score is 0.5, means it's 50% sure that that object is screwdriver. So we can set the confidence score from 0 to 1. So 1 means it is 100% sure that it is screwdriver in our case, but we can set the threshold as we like. Let's say we will set the threshold to be 0.6. So if the probability score is greater than 60%, then only it will label those object as screwdriver. So let's load. Okay, it's checking the images. Now it checked all the 3 images and the results are displayed in this file. So if you want to see what are there in this folder, we can see this is optional cell. So if we want to see the results, just to print the results, we can use this cell. So this cell will basically just display the images. So now you can see the result. See, in this image there were 2 screwdrivers, and our model could easily detect those 2 as a screwdriver. See, we had 1, and then it can detect this as a screwdriver, and for this also it detects this as a screwdriver, but it is not perfect. Anyway, it's not bad for the model which is trained with just 150 images. It's quite good. But if we want to improve our result, we have to increase the number of training data, and also we can increase the number of epochs while training. So let's see how we can check, we can pass the video. So we have already uploaded a video here, screwdriver.mp4. so we will pass screwdriver.mp4 and see how our model performs on that video. driver.mp4. so let's run. So when we pass the video file, it will break down the video file into frames and then detect for each frame. So for this video it has 681 frames, and then it is detecting the screwdriver in that frame. Okay, it finished the detection, and the results is saved in runs detect exp2. So we cannot find runs. So the present working directory is content Yolov5. So in content Yolov5, the directory is runs detect exp2 and screwdriver. So let's try to download this file. Okay, save here and let's see. Okay, now you can see it can detect the screwdriver from the real-time image as well. So our model does pretty good job, even we have trained with few images. So you can improve the accuracy by increasing the number of images, and also this time it is not you see, it's not detected as a screwdriver. It's also one thing is because we have set the threshold to quite high value. 0.6 is quite high value, like, so maybe it's also because of that we can't see the bounding box around this screwdriver. Anyway, the performance is not bad for our model. So now you can train your own object detection model by yourself.